Hello, class. We're about to start section 4, 5, and 4, 6. For section 4, 5, we're going to complete problems 1, 5, 9, and 13, starting on page 432. So let's start problem number 1. We have 1A. Let's see. We have the formula of, it says the height of a bridge arch located in 1,000 islands is modeled by the function f of x is equal to a negative 0.04 x squared plus 28, where x is the distance in feet from the center of the arch, and f of x is the height of the arch above the water of the river. So it says sketch a picture of this arch on a grid using the vertical axis as the center of the arch. Okay, now we're going to use decimals to graph this. So now let's type in this formula. We would type in y is equal to negative 0.04 x to the second power plus 28. We could take a quick look at the graph, and you notice here that we have our basically our vertical intercept as well. So this is where you all could draw a representation of the graph for 1A. Now we go to 1B. It says determine a vertical intercept. We had a vertical intercept, which is here. That's the y-intercept. So it'll be 0, 28. And it says, what is the practical meaning of this intercept in this situation? Basically, this point represents the vertex or a turning point of the arch. Okay, now we go on to C. It says estimate the X-Intercepts algebraically using a quadratic formula. Now, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, we could take this formula. So we're going to do some substitution here. I'm going to switch to this marker because there's a little glare here. So what we would have to do here in this formula here, so it'd be ax squared plus bx plus c. We know the standard form. So a is the value in front of the variable squared. And then we don't have a b, so it'd be opposite of 0 plus or minus the square root of 0 squared minus 4 times a is negative 0.04, and then c is 28. 2 times a negative 0.04. Now, when we put all of this, well, first let's rewrite this. 0 plus or minus the square root of 0. And I could put this in this calculator to find out what this number would be. It would end up being positive because so it'd be 0 plus 4.48 divided by a negative 0.08. And this will give it, x will be approximately positive or negative 26.5. So basically, when you use the quadratic formula, you're basically finding the x-intercept. So the x-intercepts will be 26.50 and negative 26.50. These would be your intercepts. Now that took care of A, B, and C. Now we're going to go to D. It says graph the function on your graphing calculator and check the accuracy of the intercepts you determine in part C. So if you go here, the intercepts are the same. So we would say the intercepts are the same. Okay, E. If the R straddles the river exactly, how wide is the river? Okay, so they're talking about the arch straddling the river. And notice that our x-intercept values are 26.50 and the negative 26.50. So we know that we would not include the negative 26.50. So what we would do, we will multiply this by 2 because it's equal distance. So we add 2 times 26.5, and then it would give us 53 feet wide. So now we will move on to D. I mean, actually, F. I'm saying D. Okay, F. A sailboat is approaching a bridge. The top of the mast is 30 feet above the water. Will the boat clear the bridge? Explain. The answer would be no. The highest point of the bridge is 28 feet. So that's it. So G, it says you want to install a flagpole on a bridge at an arch height of 20 feet. Write the equation you must solve to determine how far to the right or left of center the arch height is. 20 feet. So we would take negative the 0.04x squared plus 28, and it equals 20. Now we're just writing out the equation. They did not ask us to solve it. They just asked us to write out the equation. So the 20 only represents the y value or the f of x. So this would be the equation that you would have. Okay, H, solve the equation in part G using a quadratic formula, using your graphing calculator to check your result. Okay, so now we want to set this equal to 0. So we'll subtract 20 on both sides. So it'd be negative 0.04x squared, supposed to be plus 8, equals 0. So negative b plus or minus the square root of b squared minus 4ac over 2a. So we know b is 0. So it'd be 0 squared minus 4 times. Now a is a negative 0.04 and c is 8. 2 times negative 0.04. So when we put this in a calculator, be 0 plus or minus the square root of 0. So we'll multiply this out here. Basically, this is the same thing. 1.28 all over a negative 0.08. Now, when we put this in our calculator, it will give us plus or minus 14.14 feet. And it says, it also asks us to use the graphing calculator to check our result. Okay, let me check. So we would place this pole the pole 14.14 feet to the right or left of the center of the arch. Okay, that takes care of problem number 1. It's a little lengthy, but still we were able to get through it. Now we're going to move on to problem number 5. We had 2x squared minus 6x plus 3 equals 0. Now we're going to solve this using the quadratic formula and round to the nearest hundredth. So this is already in quadratic form. So we have a is 2, b is -6, and c is 3. So we have negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so now we're substituting our values. We have -6 plus or minus the square root of -6 squared minus 4 times 2 times 3, all over 2 times 2. So it'd be -6 plus or minus the square root of 36 minus 24 all over 4. So this would be -6 plus or minus the square root of 12 all over 4. Now, when we put this in a calculator, you will put this in the calculator as -6 plus the square root of 12 over 4, and then -6 minus the square root of 12 over 4. Now, when we put these two values in the calculator, we'll get one value that's approximately 2.37, or the other value, which would be 0.63. And this would be our final answer. Now, our next problem that we would do is problem number 9. Problem number 9 is actually on page 434. And we have y is equal to 3x squared plus 6x. And it says determine the x-intercepts of the graph algebraically and check your results graphically. Okay, so basically what you would do here is you can use the quadratic formula. And the quadratic formula, we already wrote it earlier. So we had the opposite of 6, because we know that's b, plus or minus the square root of 6 squared minus 4 times a is 3, and we don't have a c, so c is 0. And this would be all over 2 times 3. So x is equal to -6 plus or minus the square root of, that'll be 36 minus 0 all over 6. So x would be -6 plus or minus the square root of 36. The square root of 36 we know is 6. So this would be -6 plus or minus 6 all over 6. Now, when we separate this, I'm going to have to go over to another page here. -6 plus 6 over 6, or we would have negative 6 minus 6 over 6. So this will give us 0 over 6 or negative 12 over 6. So our answer would be 0 or negative 2. Now they want us to write that as X-intercept, so it'd be 0, 0, and then it also would be negative 2, 0. I guess I should be the word and here. So these are the X-intercepts for problem number 9. Now we come to the last problem, which is problem 13. Okay, with problem 13, it says the quadratic function defined by the equation d is equal to 2r squared minus 16r plus 34. Okay, so now it says the quadratic function defined by this equation gives the density of smoke d in millions of particles per cubic foot for a certain type of diesel engine. The input variable r represents the speed of the engine in hundreds of revolutions per minute. Okay, so now we have A. It says determine the density of smoke when R equals 3.5, 350 revolutions per minute. So we would take this equation, and wherever R is, we'll put in 3.5. Okay, now after we substitute and solve, our answer here would be 2.5 million particles per cubic foot. Okay, now we go here to B. It says determine the number of revolutions per minute for minimum smoke. What is the minimum output? Okay, now to find the minimum output, we would need to find the vertex, because remember the vertex is either your minimum or maximum point. So we'll do R is equal to negative B over 2A. So then we will go through here and find out B is negative 16, so it'd be the opposite of negative 16 over 2 times A, which is 2. So that'll be 16 over 4, which is 4. So that would be 400 revolutions, or 400 revolutions per minute. Okay, now the next thing we need to do is substitute in 4 in for the R values to find out what our density is. So it'd be 2 times 4 squared minus 16 times 4 plus 34, which would be 2. So it'd be 2 million particles per cubic foot. Okay, now C. It says if the density of smoke is determined to be 100 million particles per cubic foot, determine the speed of the engine. So we had 2r squared minus 16r plus 34, and we would set it equal to 100. Now what we would need to do is solve this here, typically by factoring, but now I need an extra sheet of paper here so we can finish up C. So we had 2r squared minus 16r plus 34 equals 100. Now, first thing we should do is factor out, first thing we should do is subtract 100 on both sides, because we want to make sure each side equals 0. Well, the side is set equal to 0. All right, wait a minute, let me rewrite that. It'll be 2r squared minus 16r 34 minus 100 is a negative 66, and that equals 0. Now we could factor out 2, greatest common factor, so we have r squared minus 8r minus 33 equals 0. We can actually divide that 2 off as well. Now, what we would need to do next, we need to factor this. Now, we went over factoring quite a bit in the other section, so this factors out to be basically r minus 11 times r plus 3. And we'll set both of these parentheses equal to 0. We'll add 11 here, and we'll subtract 3 here. Now we know that r equals negative 3 is not going to be part of the practical domain. So, because we cannot have negative 3 revolutions. So we have r equals 11, which is what we're dealing with. So it'll be 1100 revolutions per minute. Is the speed of the engine. Okay. So now that took care of the last part of this lesson. Now we're going to go over to section 4.6. Now section 4.6 actually starts on page 438, and it's supposed to be problems 1 through 4. But what we're going to do, we're going to cover problems 2 and 4. So let's take a look at problem number 2. It says use the following data set to perform the task in parts A through E. So we have a table. So in this table, we have an X value, Y value. So we have 0, 3, 6, 9, and also 12. So we have 5, 28, 86, 180, and 310. Now, we should put this in Desmos. I think it'll be a lot easier. So we will have, let's see, 5, well, no, not 5, it should be 0, 0, 3, 6, 9, and 12. Then we will have 5, 28, 86, 180, and 310. Okay, now on A, it says determine the approximate scale and plot these points. Okay, first of all, let's look at the points here. Okay, these are what the points are supposed to look like. Now with your scale here, your X scale, as far as in the textbook is concerned, you could start off at 0 and go by ones, and you would get all of the points you need. Now going on the side here, it looks as though, let's see, you would need to go by 30s to get up to 150, to get up to a total of 300, or a little over 300. Yeah, so you would need to go by 30s on that scale. All right, so that took care of A. Now we come here to B. It says use your graphing calculator to determine the quadratic regression equation for this data set. Now, the quadratic regression is y1. Then we have to do our tilde. And then we know it's a, b, well, actually not a, b. It's ax squared, ax1 squared, actually. AX1 squared, and then plus, then we would do BX1 plus C. Okay, now we have our regression here, and it also gives us the equation. They want us to round to 3 decimal places here. So we would end up having y is equal to 1.984x squared plus 1.590x plus 5.114. That would be our quadratic equation. Now we go to C. It says graph the regression equation using your graphing calculator. So basically we need to type this in. So we would hit, this would be easy here, y is equal to the 1.984 x squared plus 1.590x plus 5.114. So now we graphed it. And if you notice here, it basically almost exactly lies on top of this graph here. So now we go to D. It says D, use the table feature of your graphing calculator to compare the predicted outputs with the outputs given in the table. Okay, so what you could do is this here. Now that we have this equation, you can hit this wheel here and then hit the table. And then we're going to type in the numbers that we see here. 0, you notice it's a little larger than 5. Then we would do 3. We'll do 3, 6, 9, and 12. And if you notice here, these numbers are a little larger. Well, actually 3 is a little smaller. And then 6 is a little larger. 9 is a little larger. And 12 is a little smaller. So it's almost the same. So for D, basically, if we round the values to the nearest, I'm going to have to get another sheet of paper. So let me start fresh. If we round to the nearest whole number, they will be exactly the same. Okay, now we go to E. E, it says predict the output for X is 7 and X is 15. So we could just put that in here, 7 and then 15, since we already have it set up. So we could say that 113.46 and 475.364. And we're done. Okay, that's problem number 2. Now we're going to go over to problem number 4. Now, in problem number 4, we do have another table. So let me draw that table. Now, what I'm going to do, I am going to leave out one bit of information. And I will tell you why. Okay, I'm going to write out our t values because I remember our t values are years since 2012. So we really don't need to write the values above it. I guess I made this 4 quite long. So that's why I just left out those years, because all we have to do is add it to 2012, the t value. Finish writing out all of these values. Okay, now let's put this in this calculator. I'm going to get rid of all of these values that we had here. Add a table. I'm going to put in these values here. Okay, so we go up to 4, and we'll type in the 5.09, the 7.87, the 12.47, 17.93, and 27.64. Okay. So now here, this is what our graph is supposed to look like. And it tells us for A to create a scatter plot of the data using the graphing calculator. We did that. And then for B, it says use your graphic calculator to obtain a quadratic regression function for these data. Round the values of A, B, and C to 3 decimal places. So we're basically going to use that same equation that we had used before. When we typed it in the using the tilde. So we're going to do that. So let's type this in here. So we will have y sub 1, have to do our tilde, and then we will have, we're actually supposed to have a x sub 1 squared plus b x sub 1 plus c. Standard quadratic formula. And here is the graph. Now it asks us to find the equation. So this is our equation, and they told us to round to, I believe it said 3 decimal places. Yes. All right. So we have R is equal to 1.051 x squared plus 1.310 x plus 5.271. Okay, now what I need to do, I need to make one little change here because we're dealing with t instead of x. So it'd be t squared and then t. All right. So this is the formula that we have, and this was b. Now we come to C. It says graph the equation from part B on the same coordinate axis as the data points. Does the curve appear to be a good fit for the data? And if we look here, yes, it does. It almost lays right on top of the original curve. So we would say yes, and that it fits the data well. So now we do D. It says use the model to predict Facebook's revenue in 2027. Do you have confidence in this prediction? So it says here 2027. We know that's 15 years from 2012. So that means T is 15. So now what we would need to do is substitute in 15 for T here. So with that being said, we could type out the formula. Okay, so first, with this 15, if we look here at our table, these are the actual numbers. But this is 15 years later. This is well outside of our actual numbers. So what I would say, this is well outside the actual data. So it is not a good source of data. Okay, now, so that we have that out of the way, the next thing we would do is basically put this into the equation and solve it. Now, personally, I would rather just type in the equation here, this equation here. I would type in the y equals, what's that, 1.051 x squared plus 1.310x plus 5.271. Okay, now I will go up here to this wheel, get our table, and then I could just type in 15. And it will give us this 261.5 if we round, well, 261.3 if we round to one decimal place. So it'd be 261.3. That basically tells us in 2027, Facebook's revenue would be 261.3, and I believe that's billion dollars. So that's what that tells us. Okay, so now we move on to E. Now E says, in what year does the model predict Facebook revenue will reach 100 billion? So we would have R is equal to 1.051 t squared plus 1.310 t plus 5.271. Now we would substitute in 100 for the revenue. Now we could do this. We could do this in a couple ways. We could actually just put numbers here in the table, and that could help us figure this out. So let's just say if we put the number 12 in, okay, that's too large. See 10, that's still too large. Let's see 8 is too small. 9 is a little too large. So let's say if we do 8.9, yeah, 8.9 is looking good. How about 8.80, 8.88, 8.89? Yeah, so it'd be about 8.89. So it said, what year does the model predict Facebook revenue will reach 100 billion? So that would be about 8.9 years. So we will put down about 8.9 years, which would be at the end of 2020. They would reach 100 billion. And that is it. Now, if you have any questions, please, please, please email me, and I will talk to you all later.